Hello class, today we're going to be looking at the notes for EI1d, and then we're also going to take a look at our notes for EI2a. So last week we ended up looking at question number 2 as part of our review for our quiz. I want to take a look at reviewing the steps that we're going to need to solve our equations. Our first step is always going to be, to take care of any grouping symbols that we have. Now, for the most part, what we've been looking at for grouping symbols is just parentheses. We're going to see one variation of that today. We're going to combine like terms on each side individually. We're going to move our variables, then move our constants, and then either multiply or divide to get the variable by itself. Now, I've explained before, this is not necessarily an exhaustive list of every possible thing that we could do with equations, but it is going to start to get us in good habits for what we're going to be looking at in these sections coming up. So for this unit that we're in right now, these steps are going to be what we're wanting to go through step by step to solve these equations. So, and as you can see in our question number 2, sometimes I won't necessarily need to do every single one of these steps, so I didn't have to do step 1 or 2 in question number 2, but I did have to do steps 3, 4, and 5. Looking at question number 1, I again do not have any grouping symbols, there's no parentheses. I do not have to combine like terms on either side. The left side just has a variable, one term with a variable and one term without. I cannot combine those terms, and the right side just has one term. So I'm going to go ahead and see about moving my variables. In order to do so, I'm going to move my variables to the right-hand side. And I'm going to do that by adding. So right now that 3x is being subtracted, I'm going to add it in order to move it from the left side to the right side. I'm using its opposite operation. So that leaves me with a 34 on the left side and a 17x on the right. So that was moving my variables. I don't have to move my constants because my variables are already on the right-hand side and all my constants are on the left-hand side. So now I can skip down to the last step 5. I'm going to multiply or divide to get the variable by itself. So whatever is with my variable is what I want to divide. And that is my 17. I'm trying to get that 17 to where instead of being with the variable, it is away from the variable. So I'm moving the 17 from one side to the other. And here you can see in my first step, I added 3x to both sides to get 34 equals 17x divided by 17 on both sides, and my final answer is going to be x equals 2. Now if I put back that 2 up in this equation, 34 minus 6 is going to be 28, and 14 times 2 is also 28. So I get a true statement, 28 is equal to 28, when I plug 2 back in, so I know that that x equals 2 works for this equation. The next problem that I want to look at is question number 5. And this is going to put together all of our steps from above. So I'm going to just write these down real quick. My first step is to look for any grouping symbols. Then I want to combine big terms on each side. I want to move my variables using opposite operations. I want to move my constants and using opposite operations. And the last thing I'm going to do is either multiply or divide to get the variable by itself. So let's look at what we need to do for this particular equation. So looking at step 1, I do have grouping symbols. I do have parentheses. So I'm going to take care of my parentheses first, and I'm going to do that by distributing everything that is on the outside of that parenthesis. I want to multiply it through to the terms inside the parenthesis. Now this 9x is not part of this parenthesis, so I'm not going to be bringing that -5 to the 9x, just to the 3x and the 2. So let's go ahead and do this. -5 times 3x is -15x. -5 times 2 is -10. I'm going to bring my 9x down. 6 times 4 is 24x. And then 6 times -5 is -30. So that is completing step 1. Step 2, combine like terms. I do need to do that this time. On the left-hand side, I have both a -15x and a 9x, and I'm going to have to combine those. So -15 plus 9 gives me a -6x minus 10. And each time when I'm done with the operation, the one thing that I want to do on this line, I'm just rewriting everything else down so that I do not lose track. It's really easy to forget about the -10 or forget a sign or something if we're not rewriting our steps along the way. So that was step 2, combining like terms. So now I want to move all my variables to one side. I'm going to do so instead of the opposite of this -6x is a positive 6x. So I'm going to add 6x to each side. And then just get a -10 on the left and 30x minus 30 on the right. And that is completing step 3. Again, we were able to get rid of that -6x plus 6x because that just becomes 0. And I want to make sure that that sign with the 10 comes with it, because this is really 0 minus 10, which gives me a -10. So it's really important that that sign in front of the 10 belongs to the 10 and it comes with the 10. Now I'm going to move all of my constants to one side. So I'm going to do so by adding 30 to each side, because the opposite of subtracting 30 is adding 30. And I get positive 20 equals 30x. And that is completing step 4. And now I want to either multiply or divide to get the variable by itself. Well, the thing with the variable is the 30 and it's being multiplied, so I'm going to divide to get rid of it on the right hand side. And then now here I get 20 over 30 equals x. I can simplify that. I'm going to go ahead and write my answer a little bit different here. I want to write my x first. My final answer, x equals 20 over 30. And that can be simplified. Over 30, if I divide both the top and the bottom by 10, I get 2/3. And that is my final answer, so I'm going to go ahead and circle my final answer so that I can find it in all of this work. So the next problem that I want to do here is question number 9. Juan has baked a cake and wants to sell it in his bakery. He's going to cut it into 12 slices and sell them individually. He wants to sell it for 3 times the cost of making it, and the ingredients costed $8.50, and he allowed $1.25 to cover the cost of electricity to bake it. So they're asking us some questions which are going to end with how much profit is he going to make off this cake. So let's go ahead and take a look at what questions we need to answer. So how much did this cake cost to make? Well, I have the $8.50 and $1.25 for the ingredients and the electricity. If I add those two numbers together, I get $9.75. That is his cost to make the cake. So the ingredients plus the electricity, it costs him $9.75 to make the full cake. How much should he sell the cake for? Well, let's actually go ahead and take off the two numbers that I've already used. How much should he sell the cake for? I'm going to use the 3 times the cost of making it. So it cost him $9.75 to make it. He wants to sell this for 3 times that amount. So I'm going to take that $9.75, multiply it times 3, and I get $29.25. So let's go ahead and remove the 3 times, just trying to help myself stay organized and clear up clutter as I'm going. So now that we know how much we're going to sell the entire cake for, how much should he charge for each piece of cake? Well, I'm going to take that $29.25 and divide it by 12. Now see, if I'm using my long division, I actually don't get 244. I get 243.75. But that's not how money works. I only want 2 places after the decimal. So if I look here, I want to round to this second decimal spot. So I go to the next number, since that's greater than 5. I'm going to round up for the 3, and that's what gave me my 244. Now, because I did just round, I can't just simply take my $29.25 as how much money he's making off the cake. Because of that rounding, I need to take my 244 and multiply it times 12, and that'll actually give me $29.28 as how much he's going to sell the cake for. But that's not his total profit, because eaten into that, how much he's selling it for is how much it cost him to make the cake, which is that $9.75. So I'm going to have to subtract off the $9.75 from the $29.28. So $19.53 is the amount of money that he would make off of the entire cake. So question number 10 is a question that I have added here, and it's just trying to help me explain us what some of those grouping symbols look like when they're not necessarily parentheses. So again, when I'm trying to solve these problems, these linear equations, I'm going to do the following 5 steps. So I want to take care of any grouping symbols first. Now, in this problem, my grouping symbols look a little bit different. And that is because my fraction bar is actually acting as my grouping symbol. It groups the top of my fraction separate from the bottom of my fraction. So that moves this problem here up to the top. I need to take care of that grouping symbol, that fraction bar, before I can take care of anything else in the problem. So I'm going to go ahead and do that by multiplying by 3. The opposite of dividing by 3 is multiplying by 3. Multiply by 3 on both sides, and that is going to give me a v plus 9 on the left-hand side and 24 on the right, since dividing by 3 and multiplying by 3 will cancel out, or really they just become 1, and 1 times anything is just itself. So then I simply have to subtract 9 to get my final answer. If I subtract 9 from both sides, that will move my constants all to the right, and since my variables are all to the left, I am done. My final answer is 15. So I want you guys to go ahead. If you need to pause the video, please do so, but try to complete question number 11 on your own, as well as the previous questions up here for 3, 4, 6, 7, and 8. And then you'll do number 11 here. That is the notes EI2a, which is going to take us to page 15. So on Thursday last week, we talked about what different type of solutions sets we had for linear equations. We could either have one solution where we got x equals some number or r equals some number, but it was just one single solution that made that equation true. We could have no solutions if nothing worked, or we could have infinite solutions if it didn't really matter what I put in there. I could put in any number that I wanted, any real number that I wanted, and it will always hold true. When I'm looking at inequalities, though, I have similar options, but they're not necessarily going to look the same exact as when I have the linear equations. For example, when I have linear equations, I am able to have one where that doesn't happen very often with inequalities, where I just have a single solution in my answer set. We do have some that will have no solutions, not quite yet, but we will have some inequalities that just don't work. Or more often than not, our inequalities are going to have an infinite solution set. So let's go ahead and take a look at some examples here. I've numbered my number line with an appropriate scale here. And now I can grab my drawing tool, and I want to graph x equals 3. So I'm going to go ahead and put a dot at 3 and label it, and I'm done. Now, when I graph x is greater than or equal to 3, I want to start again with that same dot at 3. But now I also want all of the values that are greater than 3 as well. So that is going to be any number over here. 7 will be greater than 3, 10 is going to be greater than 3, 100 is going to be greater than 3, 1,000, any of the numbers that keep going. So I'm shading in my arrow here to indicate that not only will the 3 work, not only will all of these numbers, including fractions and decimals, everything over here is going to work, but also everything from here on out will also work to the right. Nothing to the left will work, though, of 3. So, for example, 0 is not greater than or equal to 3. So I don't want to shade anything over to the left, just to the right. So let's go ahead and take a look at what these inequalities look like. So I want to graph my critical number, which is going to be 5. Now, one unique thing about these inequalities is if I only have 1 or 2 numbers that I have to graph, I really only need to graph my critical numbers. If I'm only putting 1 or 2 numbers on the number line, then it will always be an appropriate scale for those 2 numbers. So we generally just put the critical numbers on the number line. You do have to make sure the smaller number is still on the left if there's 2. So 5 is my critical number because it is the one that I want to be less than in this case. Now I'm going to take and have an open circle here for my inequality. 5 is my critical number. It is part of my inequality, but I don't actually want to be equal to 5 in this inequality. So that's why we do a open circle at 5, and then I want to be less than that, so I'm going to shade in to the left. That would be different than having less than or equal to 5. I'm still going to have my critical number at 5, but this time I'm going to have a filled in circle at 5 because I do want to have my solutions include that 5. And then again, we're going to be less than, so anything to the left. A 4 would work. 4 is less than or equal to 5. A 0 would work. 0 is less than or equal to 5, but nothing to the right because 6, for example, would not be less than or equal to 5. Now looking at my greater thans again, I want to graph my critical point, which is again 5. want to have an open circle for this one because I do not have an equal sign, just have greater than 5, so it's going to be an open circle. And then shading to the right, because my solutions are going to be bigger than 5 or greater than 5. And then this one will again have a filled in circle with shading to the right, including my arrow. Solving for inequalities using addition and subtraction is going to work out exactly the way it does when we are solving equations for linear equations. So where I had to add 15 with my linear equations before to get the to get the variable by itself, I would do the same thing here in this problem. So I'm going to take and add 15 to both sides, and I get x to be less than or equal to 61. So 61 is my critical number. I want to have a filled in circle because I do have an equal to sign with this inequality. And then I want to go less than to the left. Now, so far our variable has been on the left-hand side, so our inequality has faced the same way as our arrows that we're highlighting. So if you want to imagine the inequality up here was kind of like an arrow facing to the right, our arrow facing to the right is exactly what we shaded. I do want to forewarn you that only works if your variable is on the left-hand side. So that pattern can be helpful, but it can also be misleading if we end up getting a solution that says 61 is greater than or equal to x, because that inequality says the same thing, that 61 is the larger number. 61 is greater than or equal to x says the same thing. X is the smaller one and 61 is the bigger one, regardless of which way you write it. But if the variable is on the left-hand side, then our arrow for our inequality will match our arrow on our graph. So looking at number 4, again, here I'm subtracting by 5, so I'm going to go ahead and add 5 to both sides, and I get x is greater than or equal to -2. This one, since again it has an equal sign, greater than or equal to, I am going to include a filled in circle. And I want to be greater than that, so I'm going to go to the right this time. So our steps for completing these is to simplify the inequality. So I'm going to either add or subtract, multiply or divide to get the variable by itself. I want to simplify that inequality. I want to have an x by itself. I want to decide whether I'm going to have a filled in or an open circle. So does it have the line underneath it or not? If it has the line underneath of it, it will be a filled in circle. If it does not have the line underneath of it, it will be an open circle. And then I'm going to shade where x is true. X needs to be smaller than 61, so I ended up shading to the left because that's where my numbers are going to be smaller than 61. I always want to read where I'm deciding where to shade, where X is true. I want to read that from the variable. I'm deciding where X is true, so I better start with X itself. X is less than or equal to 61. X is greater than or equal to -2, where are those numbers greater? So I want you to go ahead and try these ones as well. And we will discuss those during our Google Meet, and you guys can work on the homework EI2a on page 17. After that, and also let's go ahead and work on page 13 as well. If you have any questions, please let me know during our Google Meets, or you can email me and send me your questions that way as well. Have a good afternoon, guys.